Rice fields, because they're flooded, the soils are under anaerobic conditions and they emit large amounts of the very potent greenhouse gas methane. In upland cropping systems like your wheat systems or maize systems, there's a lot of emissions of nitrous oxide, which are basically derived from the fertilizer that is being applied. There's actually only about 50% of the fertilizer that is applied that is taken up by the plant. And there are a lot of microbes in the soil that perform various transformations of that nitrogen. And one of those transformations leads to the emission of nitrous oxide. Currently, we are doing a greenhouse experiment where we're looking at the potential for crops with bigger rooting systems to be able to capture more of nitrogen in the soil so less gets lost. The losses of nitrous oxide itself are very small, but in terms of greenhouse gas, it's a very important loss because the global warming potential of nitrous oxide is about 300 times larger than that of CO2. So even though those losses are minimal, in terms of climate change, they have a very important role to play.
Zinc is an essential nutrient element. If we do not have sufficient zinc, our growth is retarded, our immune system is weakened, and we are more susceptible to infection with pathogens. Our trials are in Madhya Pradesh. This is a state in India which is in the center of India. The soils on which we are focusing are soils which have sufficient zinc. The problem is that this zinc is bound in the soil, so the plants have difficulties to take it up. What we want to do is to improve the conditions in the soil so that the plants can take it up more easily. And this is done by improving the organic matter in the soil, because organic matter provides zinc to the plants. There are estimates by the World Health Organization that there are more than 1 billion, some people say 2 billion people in the world who suffer from marginal to more severe zinc deficiency. So it's a motivation, of course, that we like to do something where we have the potential that it helps mankind.
Meat consumption is always an ethical problem because people want to eat meat, and this means animals have to be killed. And in the case of chicken, the problem is male chicken cannot be used for production of eggs, so therefore you don't have any use for them and they have to be killed.
We are trying to find in the existing genetics a breed which is able to produce meat and eggs at a satisfying level. We don't want to create a new breed. We want to check what is existing in the genetics.
The products will be more expensive, so therefore it will be crucial how consumers will react to this price increase. Are they willing to pay a premium for more animal welfare? And I think that's an open question. And it's also an open question how many consumers are willing to pay for animal welfare.